The United States currently utilizes a standard electrical system based on 120 volts for residential power. This voltage level is deeply ingrained in the nation's infrastructure, appliance manufacturing, and electrical codes. While some countries around the world employ different voltage standards such as 220 volts or 230 volts, there are no active proposals or initiatives to transition the United States to a 127/220 volt system for residential use. A change of this magnitude would present significant challenges and require extensive modifications across various sectors. Firstly, nearly all existing residential electrical systems in the United States are designed and wired for 120 volts operation. This includes wiring, outlets, circuit breakers, and other components. Retrofitting every home and apartment building to accommodate 220 volts would be a monumental undertaking, involving substantial labor costs and material expenses. Secondly, the vast majority of household appliances and electronic devices sold in the United States are designed to operate on 120 volts. Adapting these devices to function on 220 volts would necessitate either replacing them with new 220 volts models or using step-down transformers to convert the higher voltage to 120 volts. Both options would impose significant financial burdens on homeowners. Thirdly, the transition to a new voltage standard would require a complete overhaul of the electrical grid infrastructure. This includes power generation plants, transmission lines, substations, and distribution networks. The costs of upgrading the entire grid to handle 220 volts would be astronomical and could potentially disrupt the delivery of electricity to homes and businesses. Fourthly, changing the voltage standard would necessitate revisions to the National Electrical Code, or NEC, and other relevant electrical codes and standards. These codes would need to be updated to reflect the new voltage requirements and ensure the safety and reliability of electrical installations. The process of revising these codes could be lengthy and complex, involving input from various stakeholders, including electrical engineers, contractors, and manufacturers. Fifthly, a transition to 220 volts could pose safety risks if not implemented properly. Electrical workers would need to be retrained to work with the higher voltage, and homeowners would need to be educated about the potential hazards of 220 volts electricity. Improper wiring or appliance connections could result in electrical shocks, fires, or other accidents. Sixthly, a change in voltage could impact the cost of electricity. While 220-volt systems are generally considered more efficient for transmitting power over long distances, the actual cost savings for residential consumers may be minimal. Furthermore, the cost of upgrading the electrical grid and appliances could outweigh any potential savings on electricity bills. Seventhly, the existing 120-volt standard in the United States has a long history and is deeply entrenched in the country's culture and economy. Any attempt to change this standard would likely face strong resistance from various stakeholders, including homeowners, businesses, and manufacturers. Eighthly, there are alternative ways to improve the efficiency and reliability of the electrical grid without changing the voltage standard. These include investing in renewable energy sources, upgrading transmission lines, and implementing smart grid technologies. Ninthly, the United States has already made significant investments in the existing 120 volts infrastructure. Abandoning this infrastructure and transitioning to a new voltage standard would represent a significant waste of resources. Tenthly, changing the voltage standard could create confusion and uncertainty among consumers. Homeowners may be unsure about which appliances are compatible with the new voltage and how to properly wire their homes. This confusion could lead to mistakes and accidents. In summary, while some countries utilize 220-volt systems, the United States remains committed to the 120-volt standard for residential power. The challenges and costs associated with transitioning to a new voltage standard are simply too great to justify such a change. The focus remains on improving the efficiency and reliability of the existing 120-volt system through various technological advancements and infrastructure upgrades. It is important to understand the fundamental principles behind voltage in electrical systems. Voltage, often described as electrical potential difference, is the driving force that pushes electrons through a conductor, creating an electrical current. It's analogous to water pressure in a pipe. The higher the pressure, the more water flows. In the context of residential power, the voltage level dictates the types of appliances and devices that can be safely and efficiently operated. Appliances designed for 120 volts are optimized to function within that specific voltage range, and operating them at a higher voltage, such as 220 volts without a transformer, can damage or destroy them. The choice of voltage standard also influences the design and characteristics of electrical wiring. Higher voltage systems generally require thicker wires to handle the increased current flow. This is because the amount of power that can be transmitted through a wire is proportional to both the voltage and the current. By increasing the voltage, the current can be reduced for the same amount of power, which allows for thinner wires to be used. However, higher voltage systems also pose a greater risk of electrical shock, which is why safety measures and regulations are crucial. In the United States, the 120-volt standard has been in place for many years and is considered a safe and reliable system. It's important to note that while 120 volts is the standard for general-purpose outlets, some appliances, such as electric ranges, clothes dryers, and air conditioners, may require 240 volts. These appliances are typically connected to dedicated circuits with high voltage ratings. The NEC provides detailed guidelines for electrical installations, including voltage requirements, wiring methods, and safety precautions. Electrical codes are constantly evolving to reflect new technologies and safety standards. Staying up to date with the latest codes is essential for ensuring the safety and compliance of electrical installations. Furthermore, it is critical to distinguish between single-phase and three-phase power systems. In residential settings, single-phase power is the most common, where a single alternating current, or AC, voltage is supplied. In contrast, three-phase power is typically used in commercial and industrial applications, where three AC voltages are supplied, each offset by 120 electrical degrees. Three-phase power offers several advantages over single-phase power, including higher power capacity, smoother operation of motors, and improved efficiency. The decision to use single-phase or three-phase power depends on the specific requirements of the application. Understanding the differences between these power systems is essential for electrical engineers and technicians. When working with electrical systems, safety should always be the top priority. It's crucial to follow all safety precautions and guidelines to prevent electrical shocks, fires, and other accidents. Always to energize circuits before working on them, use appropriate personal protective equipment, and never work on electrical systems if you are not qualified to do so. Electrical work can be dangerous, and it's important to take the necessary steps to protect yourself and others. In addition to voltage, other important electrical parameters include current, resistance, and power. Current is the flow of electrical charge measured in amps. Resistance is the opposition to current flow, measured in ohms. Power is the rate at which electrical energy is transferred, measured in watts. These parameters are related by Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. Understanding these relationships is fundamental to analyzing and troubleshooting electrical circuits. Moreover, grounding is an essential safety measure in electrical systems. Grounding provides a low resistance path for fault currents to flow back to the source, tripping circuit breakers and preventing electrical shocks. Grounding systems must be properly installed and maintained to ensure their effectiveness. The NEC provides detailed requirements for grounding electrical systems. In addition to grounding, other safety devices include circuit breakers, fuses, and ground fault circuit interrupters, or GFCIs. Circuit breakers and fuses are designed to protect circuits from overcurrents, while GFCIs are designed to protect people from electrical shocks. These devices are essential for preventing electrical accidents. Furthermore, surge protection is important for protecting electronic devices from voltage spikes. Voltage spikes can damage sensitive electronic components, and surge protectors can help to absorb these spikes and prevent damage. Surge protection is especially important for computers, televisions, and other electronic devices. In addition, power quality is an important consideration for sensitive electronic equipment. Power quality refers to the stability and reliability of the electrical supply. Poor power quality can cause equipment malfunctions, data loss, and other problems. Power conditioners and uninterruptible power supplies, or UPSs, can help to improve power quality and protect sensitive equipment. As technology advances, new electrical standards and technologies are constantly being developed. It's important to stay up to date with the latest developments to ensure that electrical systems are safe, efficient, and reliable. Continued learning and professional development are essential for electrical engineers and technicians. In summary, the United States utilizes a 120-volt standard for residential power, and there are no plans to change the standard in the near future. The challenges and costs associated with transitioning to a new voltage standard are too great to justify such a change. The focus remains on improving the efficiency and reliability of the existing 120-volt system through various technological advancements and infrastructure upgrades. Understanding the fundamentals of electrical systems, including voltage, current, resistance, power, grounding, and safety devices, is essential for ensuring the safe and reliable operation of electrical systems. Staying up to date with the latest electrical codes and technologies is also crucial for electrical engineers and technicians. It is important to clarify the differences between the various voltage systems used in different parts of the world. While the United States primarily uses 120 volts, many other countries utilize 220 volts to 240 volts for residential power. These higher voltage systems can offer certain advantages, such as reduced current flow for the same amount of power, which can lead to smaller wire sizes and reduced energy losses during transmission. However, they also require different types of appliances and electrical infrastructure. In some cases, dual voltage appliances are available that can operate on either 120 volts or 220 volts to 240 volts. These appliances typically have a voltage selector switch that allows the user to choose the appropriate voltage setting. When traveling to countries with different voltage standards, it is important to use a voltage adapter or converter to ensure that your appliances can be safely operated. A voltage adapter simply changes the shape of the plug to fit the electrical outlets in the foreign country, while a voltage converter actually changes the voltage to match the requirements of your appliance. Using the wrong voltage can damage or destroy your appliances, so it is important to take the necessary precautions. In addition to voltage, different countries also use different frequencies for their alternating current power systems. The United States uses a frequency of 60 Hz, while many other countries use a frequency of 50 Hz. Frequency refers to the number of times the alternating current changes direction per second. While most appliances are not significantly affected by small differences in frequency, some devices, such as clocks and timers, may not function properly if the frequency isn't correct. When traveling to countries with different frequencies, it is important to check the compatibility of your appliances and use a frequency converter if necessary. It is also important to note that the electrical codes and regulations vary from country to country. These codes and regulations are designed to ensure the safety and reliability of electrical installations. When working with electrical systems in a foreign country, it is important to familiarize yourself with the local codes and regulations and follow all safety precautions. In some countries, electrical work is restricted to licensed electricians, and it is illegal to perform electrical work without the proper qualifications. In addition to voltage, frequency, and electrical codes, the types of electrical outlets and plugs also vary from country to country. The United States uses a standard 2-prong or 3-prong plug, while other countries use a variety of different plug types. When traveling to countries with different plug types, it is important to use a plug adapter to ensure that your appliances can be connected to the electrical outlets. Plug adapters are readily available at most travel stores and online retailers. It is also important to be aware of the potential hazards associated with electricity. Electricity can be dangerous if not handled properly. Always follow all safety precautions when working with electrical systems, and never attempt to repair or modify electrical equipment unless you are qualified to do so. If you are unsure about any aspect of electrical safety, consult a qualified electrician. Electrical safety is everyone's responsibility. By taking the necessary precautions, we can prevent electrical accidents and ensure the safe use of electricity in our homes and workplaces.